Welcome to the first lecture on percentage. We'll start revising all the basic rules. First of all, we'll learn how to convert a fraction or a decimal into percentage. Suppose we have a fraction 2 upon 5 and we want to convert it into percentage. We'll simply multiply it by 100. So 2 upon 5 into 100, 5 cuts 100 on 20 and the result is 40%. We'll take another example. Suppose 1 by 50, we multiply it by 100 and the result is 2%. Along with this, we also need to remember all the fractional equivalents such as 1 by 2 is equal to 50%, 1 by 3 is equal to 33.33%, 1 by 4 is equal to 25%, 1 by 5 is equal to 20%, 1 by 6 is equal to 16.66%, 1 by 7 is equal to 14.28%, 1 by 8 is half of 1 by 4, so we'll divide 25 by 2, it is 12.5%, 1 by 9 is 11.11%, 1 by 10 is very easy, 10%, 1 by 11 is 9.09%, 1 by 12 is equal to 8.33%. These are some of the important fractional equivalents. Some other useful fractions are 2 by 3, which is just double of 1 by 3, so 2 times 33.33% is 66.66%. Also 3 by 4 is equal to 75%. This is also useful if your answer is suppose 23.66 and all the 4 options show 23 2 by 3, 23 1 by 3. So 66.66% is equal to 2 by 3, that means your answer 23.66 also means your answer is 23 2 by 3. So you can directly use such fractions and such percentage conversions to convert your answer into mixed fractions. Now the second rule is, suppose you have to increase a certain value by some percentage. So our basic rule would be, we'll always multiply the old value by 1 point and the percent and we'll get the increased value. We'll take an example. Suppose the salary of a person was 10,000 rupees and we increase it by 20%. So whenever there is any kind of percent increase, we'll multiply the value by 1 point and the percent increase. So in this case, we'll multiply it by 1.20. We don't need to put 0 after 2. So this decimal goes off by eliminating 1 0 and answer becomes 12,000 rupees. Suppose 10,000 is increased by 25%, so we'll write into 1 point, then we'll write 25. So 2 decimal places and 2 zeros get cancelled and our answer is 12500. So his new salary is 12,500. Suppose a person's salary gets increased by 10% and again by 10%. We need to find the aggregate percent increase or the net percent increase in the salary. We'll assume a value 100 and multiply it by 1.1 Then again there is an increase of 10%, so we'll again multiply it by 1.1. Our answer becomes 121. So the original salary was 100 and the new salary is 121. From 100 to 21, there is an increase of 21. So the net percent increase is 21%. Now, if we learn how to find out the remaining value if a certain value is decreased by a certain percent. In this case, we'll take a simple example. Suppose you had 100 chocolates and someone took 20. So you'll be left with 80. So if a value is decreased by suppose 20%, so we'll multiply the value by 0 point and 20% decrease. So 100 minus 20 is 80. We don't need to write 0 here. So we'll find the new value. We'll again take an example of 10,000. Suppose we decrease 10,000 by 10%. So we'll multiply it by 0 point. 100 minus 10 is 90, which is 9,000. Suppose 10,000 is decreased by 25%, so we'll multiply it by 0 point. 100 minus 25 is 75. So the new value becomes 7500. So the basic rule is we multiply the value by 0 point and 100 minus the decreased percent, so we get the new value. Now let's combine percent increase and percent decrease. Suppose a value was first increased by 20% and then decreased by 10%. And we need to find the net percent increase or decrease. We'll assume our value to be 100. If we increase it by 20%, we'll multiply it by 1.2. And then this increased value is decreased by 10%, so we'll multiply it by 0 point. 100 minus 10 is 90. So our new value is 108. These two decimal places get cancelled by two zeros and the result is 108. So our original value was 100. A new value is 108. So there is an increase of 8%. For such cases, we can also use other methods, which I'll tell you. The question can be, suppose the length of a rectangle is increased by 10% and the breadth is decreased by 10%. So we have to find the net percent increase or decrease in the area of the rectangle. Let's assume the length to be 100 and the breadth to be 100 again, because every square is a rectangle, so we'll take the length and breadth to be 100. So the original area was 10,000. If we increase the length by 10%, so the new length is 110. If we decrease the breadth by 10%, so the new breadth is 90. So the new area becomes 1900. So if we divide the original area by new area, so the result would be 100 upon 99. So first the area was 100, now the area is 99. So there is a decrease of 1%. The same question can be solved by other methods. Get this very clear, that if a value is increased by x% and then decreased by x%, then there will always be a decrease which is equal to x square upon 100. So we can simply calculate it by 1 into 1 is 1% decrease. For this we'll use a formula a minus b minus ab upon 100. So if a value is first increased by a% and then decreased by b%, then we can find the net percent increase or decrease by using this formula. We solve this question using the same method. The length was increased by 10%, the breadth was decreased by 10%, a into b is 10 into 10 is 100 upon 100, which is 10 minus 10 would be 0 and 100 upon 100 is 1. So 0 minus 1 is equal to minus 1. In this case, minus indicates decrease. So the result is that there will be a decrease of 1%. Now we'll take another example. We'll solve the same question using this method. So if the salary of a person was first increased by 20% and then decreased by 10%, we have to find the percent increase or decrease in the salary. So 20% increase A minus 10% decrease minus 20 into 10 is 200 upon 100, that is equal to 10 minus 2, which is equal to 8%. So the result is plus 8, which means there will be an increase of 8% in the salary. Never give the answer as 20 minus 10 is equal to 10. Now let's see another formula. Suppose the value is increased by a% and then increased by b%. So we'll find the net percent increase by using the formula a plus b plus ab upon 100. Suppose the value is increased by 10%, then again by 10%. We have to find the net percent increase. So a plus b plus a into b upon 100, which gives us 21. So the answer won't be 20%. We cannot simply add it to 20. Let's see why. When 100 increased by 10%, the answer is 110. Now 10% increase in the new value will be plus 11, which is 121. So from 100 the value goes to 121, so there is an increase of 21%. Suppose our question is the value is first increased by 20% and then increased by 10%. So find the net percent increase. 20 plus 10 plus 20 into 10 is 200 upon 100. The answer is 32%. So the net percent increase is 32%. The question can be, if the length of a rectangle is increased by 20% and the breadth is increased by 10%, so find the net percent increase in the area of the rectangle. We'll use the same formula a plus b plus ab upon 100 to find the net percent increase in the area. So the net percent increase in the area is 32%. Another type of question asked in the NIFT exam in UG and PG is, A is 20% more than B, so B is what percent less than A? We'll use two methods to solve it. Let's take the reference value. Suppose A is 20% more than B. We'll take B as 100. So A will be 120. Now our formula is difference 200 upon reference. In this case, the difference is 20. Reference, earlier the reference was B because the question says A is 20% more than B, so B is the reference. In the second case, you have to find B is what percent less than A, so the reference is now A. If we solve it, 0 gets cancelled by 0 and this gets cancelled by 6. So the answer is 16.66%. I hope you all remember the fractional equivalent of 1 by 6, which is 16.66%. Another method to solve such questions is, suppose there is a value which is 1 by n more and we have to find less, so the answer will be 1 by n plus 1. In this case, 20% is equal to 1 by 5, so the answer will be 1 by 6, which is equal to 16.66%. Suppose the question had been A is 25% more than B, so B is 4% less than A. We will not use this method. So 25% is 1 by 4, so answer will be 1 by n plus 1, 1 by 5, and the answer is 20%. The question can also be, if there is an increase in the price of sugar in a town by 25%, so by what percent should a housewife reduce her consumption in order to spend the same amount as before? So increase in price is 25%, so increase is 1 by n, 25% is equal to 1 by 4. So the percent reduction in the consumption will be 1 by 5, which is equal to 20%. If the question says A is 20% less than B, so B is what percent more than A? Just the opposite. So suppose B is 100 and A is 20% less, so A is equal to 80. The first method we'll use the formula difference into 100 upon reference. Our difference is 20 and our reference is A is 20% less than B. So the reference was 20. Now it says B is what percent more than A. So the new reference is A, which is 80. The answer is 20 upon 80 is 1 by 4, which is equal to 25%. If we use our alternative method, suppose the question says less is 1 by n and we have to find more. The answer will be 1 by n minus 1. 20% is equal to 1 upon 5. And 1 by n minus 1, which means 1 by 5 minus 1 is 1 by 4. And 1 by 4 is equal to 25%. See, the answer is same. And the second method will take around 5 seconds. Let's change our question. Suppose A is 25% less than B and we have to find B is what percent more than A. 25% is equal to 1 upon 4. So the answer has to be 1 upon 4 minus 1, which is 1 upon 3, which is equal to 33.33%. So if the question is that the price of tea in a town gets reduced by 25%, so what percent more tea is available for the same price? So 25% less means 1 by 4, so more will be 1 by 3. The answer is 33.33% again. So now we'll again revise the basics. The word percentage in the simplest sense means per 100 or upon 100. To convert a fraction or decimal into percentage, to multiply it by 100. So 0.2 into 100 is 20%. 1 by 3 into 100 is 33.33%. If you want to convert a percent into fraction, so we'll divide it by 100. So 20% is equal to 20 upon 100, which is equal to 1 upon 5, and we drop the percent sign. If the question is what is 25% of 500, either will write 25 upon 100. In maths, of means multiply. So 25 upon 100 into 500 is equal to 125, or we know that 25% is equal to 1 by 4. So we'll divide 500 by 4, which is again equal to 125. The question is what is 10% of 20% of 200. So 10% of 20% of 200 is equal to 4. Suppose the question is what percent of 30 is 15. We can also reframe the question. So 15 is what percent of 300. So 15 is what percent of 300. The answer is 5%. Let's come to percent increase or decrease. If we have to find the percent increase, we'll use the formula increase upon original value into 100, or the formula used earlier was difference upon reference into 100. For percent decrease, the formula will be decrease upon original value into 100. The two examples are the salary of an employee was increased from 10,000 to 15,000, and we have to find the percent increase. So the difference is 5,000 and the reference is 10,000. So 5,000 upon 10,000 into 100 is 50%. Suppose the value of a product got decreased from 40,000 to 32,000. We have to find percent decrease. Our reference value is 40,000. Earlier the value was 40,000. Now the value is 32,000. So the difference is 8,000. The original value was 40,000. So 8,000 upon 40,000 into 100 is 20%. I hope you all remember the fractional equivalents now. 1 by 2 is 50%, 1 by 3 is 33%. We also have gone through percent increase and the multiplying factor. Suppose a value is increased by 10%, we'll multiply it by 1.1, by 20%, 1.2, by 30%, 1.3. But if the value is increased by 9%, so we cannot multiply it by 1.9 because it will be 90% increase. So we'll multiply it by 1.09. So whenever the value is increased by a percent that is less than 10, we'll write 0, 9, 0, 8, 0, 7, 0, 6. In this case, the value is increased by 2%, so we'll multiply it by 1.02. In case of percent decrease, the multiplying factor is, suppose 10% decrease, we'll multiply it by 0. 100 minus 10 is 90. 20% decrease, 100 minus 10 is 80, so we'll multiply it by 0.8. Suppose we decrease the value by 9%, we'll multiply it 100 minus 9 is 91, so we'll multiply it by 0.91. Let's again revise successive percent method. Let's say in the first year A's salary increases by 10% and in the second year the salary increases by 20%, and we have to find the net percent increase. The basic method is from 100 after 1 year the salary becomes 110. Now from 110 after a year, 10% increase. If we have to increase a value by 10%, to find 10% simply put a decimal here. So 10% of 110 is 11. Add 11 to 110, the answer becomes 132. So the original value was 100, new value is 132, there is 32% increase. We know the formula a plus b plus ab by 100, so we can use it. So 10% increase plus 20% increase plus 10 into 20 upon 100, which gives us 32%. Or we can assume the value to be 100. We increase it by 10%, then we increase it by 20%, the result is 32%. We did this question, the length of a rectangle increases by 30% and the breadth decreases by 10%, and we have to find the net percent change in the area. Method 1 is area of a rectangle is length into breadth. So area is L into B. If we increase the length by 30%, so we'll multiply the length by 1.3. If the breadth is decreased by 10%, we'll multiply the breadth by 0.100 minus 10, 90. So if we remove the decimals, LB cuts LB, it becomes 100 upon 117. So the area was 100, now the area is 117. So there is an increase of 17%. Another method to solve such question is, if there is an increase of 30% and then decrease of 10%. So A minus B minus A into B upon 100. 30% increase, 10% decrease. 30 into 10 is 300 upon 100. The answer is 17. Plus means increase. So there is an increase of 17%. Now next question. The length of a rectangle is increased by 10%. So what percent reduction should be made in the breadth to keep the area same? We'll use the formula A minus B minus AB upon 100. If there has to be no change, then the answer should be 0. Now in this case we have to find B. So if we solve the equation, the value comes to be 9.09%. So if we increase the length of a rectangle by 10%, so we have to reduce the breadth by 9.09% in order to keep the area same. I told you another method. If there is an increase of 1 by n, then the decrease should be 1 by n plus 1. So the length is increased by 10%, which is equal to 1 by 10. So the decrease has to be 1 by 10 plus 1, which is 1 by 11, which is equal to 9.09%. So this will take hardly 2 seconds. Now, if the salary of a person is first increased by 10% and then decreased by 10%, we have to find the net percent increase or decrease in the salary. In such questions, the value will always decrease. So never mark your answer as no change. Suppose the original salary was 100, we increased it by 10%, the salary became 110. Now, if we decrease 10% of 110, the new answer is 99. So the salary was 100 and the new salary is 99. So there is a reduction of 1%. So we can use this method. Whenever there is an increase of d% and then decrease of d%, there is a net decrease which is equal to d square upon 100. So in this case, 10 square upon 100 is 1% decrease. We can use the method a minus b minus ab by 100. The answer will be same. There are a few questions which you can solve. We have given 2 exercises in the booklet. You can solve these questions on the basis of the methods I've taught you, and we'll discuss everything in the class.